So good afternoon. I'm Manish and along with me Arun. Today we are talking about AI assist unit and integration test framework for OpenBMC. So this is outline what we are discussing today. So we will first give you the background, what this unit testing framework for and what is the area we are focusing this unit testing framework. Then we'll tell what problem we are trying to solve using this unit testing framework. Then overall we'll discuss about the test framework architectures, modular unit testing, fault injections and integration testing. And finally, as this testing framework to have more fine-tune and generate more test cases, we will have AI assistance to improve the code coverage. And as you see, nowadays code is become more and more complex. To have an simplified maintainable code, we'll have AI assist cyclomatic complexity computation, which in turn make helpful for testing efficiency. So now I'll give you a little background. So let's say if you see server product life cycle, it starts from the POC, then engineering validation test, then design validation test, production validation test, and finally volume productions. And each phase of this server product lifecycle, there are different test scenarios, different test unit. If you see POC, let's say 10 unit you will start, then it will go to 1K, and mass production you have that production related servers. So each phases, if you see, different kind of test scenarios are there. There are some stress tests, regression tests and all. And based on the requirement of that particular phase, scenario will be different. So this is one aspect. So next things, if you see, so there are different server manufacturers. They have different CPU architecture, different platform architecture. So test scenario will vary based on that. So now we'll talk about the framework. So basically framework for what we are trying to propose, so which is in BMC. So which is baseboard management controller, which you can say that black box to the server. It is present most of the server motherboard, and it enables remote monitoring to maintain the health and availability of the server. So if you see in diagram, that platform software which I mentioned, where host CPU will sit, it has BIOS, UEFI components, then they have multiple sensors, then power supply unit, then we have multiple add-in card, let's say graphics card, SSD, GPU card, and all kind of things. So it will talk to all this component, get the manageability in inventory data, and it will make sure that server health is at par. So now what is the OpenBMC? OpenBMC is Linux Foundation open source project that produces open source implementation of BMC firmware stack. So now after little background about what is about and where we are heading about this framework, so we'll start with the problem statement. So if you see any kind of validation you are doing, so there are scenarios wherein if you want to test some scenarios with faulty hardware or inject, there are some scenarios at customer end where is happening, and we want to try to replicate that same environment here or at our place. There are difficulties, availability of hardware, similar environment, some other platform configuration and all. And always it's difficult to generate that fault for, let's say, power supply unit, add-in cards, CPU, and etc. Then another point is like, let's say if you are going through different phases, I explained like from POC to engineering validation, design validation, and we want to test some scenarios, consider the graphics card, or let's say consider the CXL card, manageability of the CXL card, and then that particular card is not available, then there are chances like that phase will get delayed or postponed, considering because validation final, that result of validation is required to go for next phase. So definitely that will become again delay in the life cycle or final output for that server productions. So this is one aspect we are focusing. Another aspect, if you see, right now OpenBMC is, you see that different repositories, they have different functionalities, different services. So, and let's say I'm working on, let's say one model, so I'll see that this model, and I'll write a code on that particular model and see, I'll see that it well defined within that model. But there are chances like I'll miss some functional scenario while writing the code. So technically code might be right, but functionally it might be hitting some scenarios we should not be hit. So that is another problem we are trying to focus on. Now we'll talk about overall what is a test framework about. So first we'll talk about what is the module level testing. So as I mentioned that OpenBMC has multiple models. So we'll first focus on what is module-based testing. Then we'll see that fault injection, how we can have using this model-based testing. Then we'll have integration testing, which is, I'm talking about the functional scenarios. And then finally report, alert, and deployment. So now we'll start with modular testing. We'll start with stub. So what is a stub? So stub is an interface which simulates a real object. So now if you see this is OpenBMC code, for simplicity I divided into the 3 modules, let's say sensor module, add-in cards, manageability, and PSU, power supply unit. So let's say the hardware call getting, we are getting real-time data from all these models. So here stubs means instead that data going to the hardware, we are simulating using our own call, and whatever possible returns value from that particular hardware, we are simulating with our own data structure. So using this, we will be checking behavior of the OpenBMC code in case of different test scenarios. Now, this is again core part of this framework. It is simplified wrapper interface generator, which is called as SWIG. This is open source framework. So using this, you can get the C++ code and access in JavaScript, Perl, Python. So right now if you see, there is an C++ code, simple addition. Then you get that C++ code, have interface file. This is a mapping file for SWIG. Then you get that file, generate a wrapper code using SWIG. So that C++ code can accessible to Python. So here I mentioned about the Python. You can have whatever language you want to have the framework. So now then take that code and then create a shared object. And finally, if you see that import.example, which is a C++ code we are importing into Python. So basically, we are calling the C++ API inside the Python, because you see Python is widely used in the validation. There are already well-defined unit testing framework are available. So that we are trying to use this approach. Now, as we talk about the modular testing, now we'll take that one example. Let's say if you see right-hand side, what I talk about, OpenBMC code, writing a stubs, then SWIG, then finally importing that C++ code into the Python. And consider that there are 3 models. So this, let's say, as in when you get that model inside the Python, you will write the test cases. So different kind of test cases you write, and that become a test suite. So you have test suite for sensor, PSU, and add-in card. So this is individual test code. Then you can aggregate all these test code, then it will become OpenBMC test suite. So this is like what you can say aggregated test suite, modular test suite for OpenBMC. Now we'll talk about the framework architecture. So if you see this OpenBMC test suite will club with the functional scenarios. So functional scenario means, so let's say OpenBMC is widely adopted in the server industry. There are different kind of server manufacturer vendors available there, and they have different kind of test scenarios. So one example I'll give you, let's say generally fans are powered by 12 volts. So it's same that host processor is get powered out. So host system is let's say down. So then BMC will report that fan sensors are not available. This is one typical commonly used functional scenario. So let's say if you want to, so somebody says like, yeah, fan sensors are not available. I think first thing to think whether host is on or not. So this will learn all these things by experiment or understanding that particular thing. But let's say new developer want to contribute to OpenBMC, or somebody who wanted to validate OpenBMC. In that case, there are some learning curve to understand the functional scenario. So in this case, we can have that functional scenario club with this framework. Then another, with that, we can have inject failure. So basically, we can, let's say PSU over current, PSU over voltage, that kind of things. It's difficult to simulate, and if you simulate, there are chances of risk of hardware. So using that, we can club together all these scenarios, modular testing, integration testing, failure injection, and we can have deploy this in CI/CD with alerts available. So now we have done feasibility on the sensor monitoring part of OpenBMC. OpenBMC has a variety of the repositories. So there is one repository called as Rebus Sensor, which takes care of sensor monitoring, reading data from the sensors. So here if you see hardware mon subsystem which plays crucial role in monitoring that particular all the sensor, let's say CPU, DIMM and other parts. So what we will do, like here we can take that hardware mon call, replace with stubs, write our own data structure, create OpenBMC module, let's say sensor module, write a test cases, and then create a suite. And finally, we'll have the functional test cases like sensors are depending on something. So that's how we can have further implementation. Yeah, now Arun will talk about further about AI assistance in test case generation.
Yeah, so now Manish has covered on the framework aspect. So now further on the AI or the machine learning aspect of the framework is to generate the test cases for wherever the coverage is missing. So for that, what we are trying to do is like we are using some pre-trained model. We are looking into that, and then using some of the parameters like platform configurations and an OpenBMC code and also some functional scenarios. So we are fine-tuning the models and building an fine-tuned model which is very specific to BMC and OpenBMC. So then the fine-tuned model would become very specific to platform configuration and OpenBMC code. And once you have the model to infer the code generation for not covered code, so we could use standard any standard code coverage tool to get the coverage result, and missing coverage could be generated using this fine-tuned model. So we are figuring out what right model to right pre-trained model to be looked at. So now another aspect of this tool is like we are looking at cyclomatic complexity of code. So cyclomatic complexity is a matrix that gives program structure or program complexity, and the control flow complexity will be measured. So this is something that we are integrating as part of this tool to have a better simplicity of code, so that the test suite or unit test are not complex, or the unit tests are like simple enough. And the standard methods are like you use manual process like CFGs, a control flow graph, or static tools to do this approach. That's where so this is primarily, and in another aspect to that is we are also working on a sustainable software design. Today we had a presentation. So one of the aspects for sustainable software design is to have simple software. So having the complexity analysis would bring simple code, and it contributes to sustainability as well. Yeah, so yeah, that's it about the cyclomatic analysis. So now the call to action is, as Manish said, we did certain feasibility study for sensors, so using DBus sensors repo and for the OpenBMC, and then further we want to cover more other repository of the OpenBMC side, and also we want to have a framework which is robust enough to address all these challenges. And also, as I discussed before, the AI part feasibility which we are working on to improve the code coverage. So, and also we are looking for collaborating and in terms of this particular framework. Yeah, so and these are all the references that we kind of looked at while presenting. Yeah, thank you.
Thank you.